Okay, guys, on page 9, we are looking at another couple of theorems. What happens if two secants or chords intersect inside of a circle? Then we are going to take the measure of the arcs that we are interested in the angle measures of. We are going to add them together and divide by 2. Okay? So in our first example, we want to know what the measure of angle 1 is. So I'm going to take the degree measure of AB and the degree measure of DC. Add them together and divide them by 2. That's it. Pretty simple. Right? Well, slightly more complex, but not really. If a tangent and a secant, two tangents or two secants, intersect outside of a circle, that angle measure is half the difference subtraction of the intersected arcs. So the way I think of it is big arc minus little arc divided by 2 gives me that angle measure. So our formula box in the middle of the page should be highlighted. It should be starred. It should be celebrated because this is going to give you all you need to know all you need to know to be able to solve problems involving circles with arcs that are either central arcs or central angles if the vertex of the angle is on the circle, inside the circle, or outside the circle. Right? So in example 1, we have an arc measure of 100. That means our central angle measure matches, right? Because we've seen this earlier. If angle 1 is 100, then the arc is 100. Well, it works in reverse. If the arc is 100, then the center angle is 100. We haven't really looked at on very much. This is what it looks like. A tangent and a secant creating an angle, and that angle opens up an arc. It's pretty big in this case. Now, in this example, I don't have a measure here, but I've got everything else. Okay? That's what I'm given as 95. So I'm going to take 360, subtract 95. That is going to give me the length of this other piece of the circle, this unknown arc. Once I have that at 265 degrees, I'm going to my on equation, and it says the angle measure is the arc, 265, divided by 2. So I did that, put it in my calculator, and got 132.5 degrees. 132.5. What happens if they intersect inside? Okay, so they've made an intersection on the inside of the circle, but not at the center. Okay, well, our directions for inside say a big arc plus a little arc divided by 2. I don't do big and little arc on this one. It's just the angle measure of interest and its arc, and the vertical angle and its arc. So in this case, I'm interested in the angle measure for 1. It opens up to 110. Its vertical angle opens up to 45. I add them together, divide by 2, and in this case, I get 155 divided by 2. And my calculator told me that half of that is 77.5 degrees. Pretty snazzy. Last one on this page. If I have an outside angle of interest, or angle 1 out here, then I am going to take the big arc that is made by that angle, and I'm going to subtract the small arc from that angle. Then I'm going to divide it by 2. Okay, so big arc minus little arc, or far away minus near, divided by 2, And in this case, it's 175 minus 40 divided by 2. When I put that into my calculator, I got 135, but I neglected to divide that by 2. Oh, bad, Miss Hart. Not a good thing. Not a good thing at all. So 135 divided by 2 is going to give me a final answer of 67.5 degrees. Okay? And I will put a box around that. That should be degrees, not a floating in the air 0. There we go. And that is how we are going to be able to calculate angle measures given their positions and the pieces that make them up in the circle. By the same token, we can do what we've done with angle measures with the chord length, which is pretty neat. Okay? So on page 10, I have color-coded the pieces depending on whether we have an inside intersection of chords, an outside intersection of secants, or if I have an outside intersection of a tangent and a secant. Okay? Don't get these two confused. Okay? Follow the setup. So if I have these intersecting chords on the inside, I have a part A and a part B. On the other chord, I have a C and a D. And the way it works is I'm taking part A times part B and setting it equal to part C times part D. And you can see that I've got that written out as an equation. So let's do example number 1, where I have exactly this setup. I am going to go through and label each of the pieces. Okay. So in purple, I'm going to label A as 14. I'm going to label B as 15 because they're the same or on the same line. I am going to label C, which is currently my X, and D, which is 10, and those are my pieces. Now I'm going to fill in the matching equation. Okay. So I have A, 14, times B, which is 15, equals C, which is X, times D, which is 10. And I did this in my calculator earlier so that I could do this. And 21 units equals my X portion of that chord length. So I'll write units down here because I did a bad job and did not leave myself enough room. All right, the next one with these two secants intersecting outside of a circle. We are going down to example 5. Okay. And I'm still going to use, let me see if I can get all of that on the page. There we go. The same thing. I'm going to label my parts. I have an outside upper piece called A. My outside upper piece here is 8. I'm going to label that with an A. Its extension inside the circle is B, which is currently 3x plus 4. My outside lower piece is C, which in this case is 7. And my extension of C inside the circle is a purple D, and that is currently 5x plus 2. I'll mark that in a little better as 2. So I, again, am just going to follow the equation that I have been given. A portion times A plus B, and I should put this in parentheses, equals C portion times, in parentheses, C plus D. Okay? So A times the whole equals C times the whole. Okay? I'm not expecting you to memorize that, but it will be helpful to understand where the pieces are moving around. Okay. But again, I'm just going to fill in what I've got. My A is 8, so 8 times A plus B, 8 plus my B is 3x plus 4, equals my C, which here is 7, times C plus D, 7 plus 5x plus 2. Right? All I've done is fill it in. Now I'm going to combine like terms inside these parentheses. So 8 times 12 plus 3x equals 7 times 7 and 2 is 9 plus 5x. And I'm going to distribute the 7 to the parentheses. I'm going to distribute distribute the 8 to the parentheses, the 7 to the parentheses, and then it's just an algebra problem. Okay? 8 times 12, because I did that on my calculator earlier, is 96 plus 24x equals 7 times 9, 63, plus 35x, distribution property. Now it's just an algebra equation. Move it up a little bit. I'm going to keep my variables on this side because 35 is bigger than 24, and move my constants to this side. So subtract 63 from both sides and subtract 24x from both sides. Big calculation line. And I get 96 minus 63. So 33 equals 35 minus 24 is going to give me 11x. Divide both sides by 11, and x equals 3. Okay. Now, usually I'm like, oh, you've got to have units. Well, I don't, because 3 is actually a value inside a length. So we haven't gotten to what the length is. I wasn't asked to do that. I was asked to find the value of the variable. I have found the value of the variable. It is not a length. It does not need a unit of measure. All right, last kind. When I've got this tangent and a secant intersecting outside of a circle, I am going to take the tangent times the tangent, so a squared, and set that equal to, again, Miss Hart, you forgot the parentheses, the outside piece times the entirety, or b times b plus c. Again, let's label our diagrams. It will make our lives easier. And I am going to do number 8 as the example to use. And I will have to make it a little smaller so that I can have everything on the same page. Nope, one more smaller. Sorry. Okay. All right, my tangent, my lonely tangent piece outside is A. My lonely tangent piece on the outside of number 8 is X. So I'm going to label that as my A. The outside piece of my secant is my B. I'll label it that way. And the inside of the circle piece is C, or in this case, 21. So I have labeled all of the pieces of my diagram. and I'm just going to fill it into the equation that I have been given. So a, in this case, is x. So where am I going to put it? X squared equals b, in this case 27, times b plus c, 27 plus 21. Okay. All right, so I've got this 27 plus 21. That is going to give me 48. I am multiplying it by 27. X squared has had no action taken on it. And because I already did this in my calculator, I get 1296 equals x squared. And I'm going to take the square root of both sides. And I get x equals 36. Now, because that x is actually a length, it's not just part of the equation, it is definitely going to be in units. And that is my final answer for the length of this tangent piece using my equation for a secant and a tangent intersecting on the outside of a circle.